We have an all-new battery pack. And then something we're really proud of is the new carbon-sleeved rotors for the motor. So this is the first time that...
Have you ever wondered what would happen on the day when one company, just one company, suddenly moves far beyond everything the electric vehicle industry has ever known? Not just one step ahead, not just one generation ahead, but so far ahead that every remaining competitor has to sit back and ask themselves, who the hell are we competing with? A few weeks ago, when Elon Musk stood on stage and introduced Tesla's latest electric motor, most people thought it was just another normal technology showcase, a product launch, a few impressive numbers, some applause, and then everything would go back to normal. But no, this time was completely different. Because what Tesla just unveiled is not simply a stronger or lighter motor, it is a complete redefinition of how we understand what an electric motor is, what it can do, and how far it can go. With a carbon fiber sleeve wrapped around the rotor, with a spinning speed beyond 20,000 revolutions per minute, with the ability to accelerate from 0 to 60 miles per hour in less than 2 seconds, Tesla has just pulled the entire EV industry onto a completely new level, and most rivals have not even realized it yet. But here is the part that is truly worth thinking about. Tesla is not hiding the secret. They open the patents to everyone. Any automaker in the world can read them, study them, and try to copy them. So why does that not make Tesla lose its advantage? Why can you know the recipe and still not cook the dish? And more importantly, how will this affect millions of people who are thinking about buying an electric car over the next few years? Can other brands catch up, or are we witnessing the beginning of an era where Tesla becomes the undisputed ruler? Those are the questions we're going to explore in today's video. And I promise you, the deeper we go, the more surprising this story becomes. Before we begin, if you enjoy in-depth analysis videos like this, videos that do not just report the news, but explain why it matters and how it changes everything, hit the subscribe button right now. Elon Musk turns a crazy dream into a global threat. To understand why Tesla's new motor is causing such a shock, we need to step back a little. Not just a few years, almost 20 years. In 2003, when two young engineers named Martin Eberhard and Mark Tarpenning founded Tesla Motors in San Carlos, California, the auto industry saw it as a joke. Electric cars at that time, if they existed at all, looked like golf carts with windows added to them. No real power, no meaningful range, no one truly wanted to drive them on a highway. The idea that electric cars could compete with gasoline cars in performance, design, and driving feel was completely dismissed by industry experts. Nobody believed it. Not a single major automaker wanted to bet on that future. Then Elon Musk appeared. In 2004, when Musk invested in Tesla and became its largest shareholder, he did not just bring money. He brought a completely different way of looking at what electric cars could become. Not cars for environmental activists, not budget-saving vehicles. In Musk's eyes, an electric car had to be the most beautiful, fastest, and most exciting thing you had ever sat in. In 2008, Tesla launched the first Roadster. Built on a Lotus chassis, this car was faster than most gasoline sports cars in its class. It proved one simple but revolutionary thing. An electric motor could produce real power. Not fake power on paper, real power you could feel when you pressed the accelerator and your back was pushed deep into the seat. Then came the Model S in 2012, a luxury sedan with a giant touchscreen, over-the-air software updates, and enough performance to make BMW and Mercedes seriously uncomfortable. After that came the Model X with falcon wing doors, then the more affordable Model 3, which opened the door to the mass market. Then the Model Y, then the Cybertruck, with a look like a broken spaceship. Every product triggered a reaction across the industry. Traditional automakers began rushing to launch their own electric versions. Ford introduced the Mustang Mach-E. GM poured billions of dollars into the Ultium platform. Volkswagen launched the ID series. Hyundai and Kia suddenly became serious names in the EV segment. Many experts at that time started saying that Tesla had already peaked, that its golden age was over, that once the big players truly entered the race, Tesla would no longer be anything special. They were wrong. Because while everyone else was trying to catch up with what Tesla had already done, Tesla was secretly preparing for the next leap. a leap that almost no one in the industry really predicted. But to understand why that leap matters so much, we need to look at the core of the entire story. Inside the motor that is changing the world, when Elon Musk walked out and introduced the new plaid motor with a carbon sleeve, many people's first reaction was, "That sounds cool, but is it really different?" The answer is yes. And the difference goes much deeper than what you can see from the outside. Let's start with the heart of every electric car. The rotor, the spinning part inside the motor that is responsible for turning electrical energy into mechanical motion. In most electric motors today, the rotor's made from copper and steel alloys. These materials have worked well for decades, but they have a very clear physical limit. When rotational speed rises, the centrifugal force acting on the rotor increases exponentially. At a certain threshold, the material begins to deform. More heat is generated, precision drops, and the whole system starts losing efficiency exactly when you need it the most. Tesla solved this problem with a solution that is simple in concept but extremely difficult in execution: wrapping the rotor in carbon fiber. Carbon fiber, the material you see in Formula One cars, aircraft, and space equipment, has a far better stiffness-to-weight ratio than steel. It is lighter, stiffer, and especially much better at handling tensile force at high speed. When Tesla wraps this carbon layer around the rotor, it creates an external compressive pressure known as preload that keeps the rotor structure stable even when it spins at extremely high speeds. The result? Tesla's rotor can go beyond 20,000 revolutions per minute, a number that most conventional electric motors never reach. And that rotational speed directly creates the power and acceleration you feel behind the wheel. That is why the Model S Plaid can reach 60 miles per hour in less than 2 seconds. Until recently, that number only existed in million-dollar hypercars like Bugatti or Koenigsegg. Tesla just put it into a family sedan. But speed is only one part of the picture. The more important part is energy efficiency. Because the rotor is lighter, the motor needs less energy to spin. That means with the same amount of electricity in the battery, the car can travel farther. That means the cooling system does not have to work as hard. That means battery life can be extended. All of these benefits work together and create a positive feedback loop. A more efficient motor, a more durable battery, longer range, and lower operating costs. And there is one more factor that is often overlooked in discussions about performance: thermal stability. In conventional motors, heat is enemy number one. When temperature rises, metal expands unevenly, causing microscopic imbalance inside the motor. Over time, this leads to wear and reduced performance. Tesla's carbon sleeve does not expand in the same way. It maintains consistent compressive pressure no matter how the temperature changes, helping the rotor stay stable under all operating conditions. In other words, this is not just the fastest motor Tesla has ever made. It is also the most durable, the most stable, and the most efficient, all in one design. It may sound simple at first, but this small detail could be the thing that changes the entire game. The secret is hidden where you least expect it. Now, this is the part that truly amazed me when I first read about it. Wrapping carbon fiber around a metal rotor does not sound too complicated in theory, but in reality, this is one of the hardest engineering challenges Tesla has ever faced. Why? Because carbon fiber and metal, especially the copper and steel inside the rotor, have different thermal expansion coefficients. To put it more simply, when the temperature changes, these two materials expand and contract at different speeds. If you simply wrap carbon around the rotor without extremely precise calculations, when the temperature rises during operation, the carbon layer can peel off, crack, or worse, cause severe imbalance at 20,000 revolutions per minute, and you can fully imagine what would happen after that. To solve this problem, Tesla had to build an entirely new robotic system from scratch, controlled by artificial intelligence, capable of applying the carbon layer with micrometer-level precision. Not millimeter, micrometer, meaning 1,000th of a millimeter. This system controls everything at the same time: the tension of the carbon fiber throughout the wrapping, the ambient temperature, the wrapping speed, the angle at which the fiber is applied, and then it verifies the result with laser sensors to make sure there's no deviation at all, even the smallest one. Every rotor is individually inspected before being installed into the motor. This is the key point. Tesla patented this carbon sleeve technology and then opened it to the entire world. Anyone, any company can read the design. But the design is not the machine. You know the secret, but you do not have the machine to execute that secret. You do not have the artificial intelligence system trained through thousands of tests to know exactly how much tension is enough. You do not have the quality verification process refined over years. And even if you had all of that, you would still need to integrate the entire thing into a production line at the scale of tens of thousands of units per month. This is Tesla's genius strategy. Opening patents is not about being generous, it is about showing the gap. They're telling the whole world, we have gone so far that even if you know all our secrets, you still cannot catch up. But no matter how good a technology is, it means nothing if it cannot be produced at scale. The challenges Tesla does not want you to remember. Of course, not everything is perfect. And if we only praise Tesla without looking at the real risks, then this is not honest analysis. So let's speak directly about the challenges Tesla is still facing. First, production cost. Carbon fiber sleeve technology with micrometer level precision is not cheap. Each rotor requires machine time, quality inspection, and expensive materials. While Tesla is rapidly expanding output, the production cost of each plaid motor is still significantly higher than a conventional motor. This raises a question. Can Tesla bring this technology into mainstream models like the Model 3 or Model Y? Or will it remain a privilege of the high-end segment forever? Second, financial pressure. In 2024, Tesla had to carry out major layoffs and faced questions about shrinking profit margins as the price war with Chinese competitors became increasingly intense. BYD, SAIC, NIO, these names are no longer small startups. They are producing millions of cars at much lower costs, and they are aggressively expanding into international markets. In a price war, better technology does not always win. Third, too much dependence on one individual. Elon Musk is a marketing genius and the strategic mind behind many of Tesla's breakthroughs. But the brand's extremely close connection to him is also a risk. The controversy surrounding Musk on social media platforms, his divisive statements, his promises that were not delivered on time, all of these affect consumer trust in Tesla. And for buyers aged 45 and above, people with enough experience not to be easily swept up by hype, trust matters more than speed. Fourth, charging infrastructure. Tesla's supercharger network is still one of its biggest competitive advantages in the United States, but as Tesla opens superchargers for other brands to use, that advantage becomes less exclusive. At the same time, range anxiety remains a major psychological barrier for many buyers in states without dense charging networks. And fifth, uncertainty around self-driving. Tesla has been promising full self-driving for many years. The technology has made significant progress, but it still has not reached the level Musk once promised. This creates a gap between expectation and reality, and that gap damages credibility. These challenges do not erase what Tesla has achieved with the plaid motor, but they remind us that in the real business world, the best technology does not automatically lead to market victory. Many other factors have to line up at the same time. And this is exactly where the race becomes even more intense, because Tesla is not the only company trying to dominate the future. The ones who refuse to give up. When Tesla announced the plaid motor with its carbon sleeve, competitors reacted in many different ways. Some stayed silent, some dismissed its importance, and some quietly accelerated work inside their laboratories. Let's look at each group. Lucid Motors is the most dangerous rival in terms of pure engineering. The Lucid Air Grand Touring performance has a range of more than 500 miles, a number the Tesla Model S still has not reached, and Lucid's drivetrain is designed with an impressive level of technical sophistication. But Lucid is facing a serious problem: sales. They only produce and sell a small number of cars each year, mainly serving the ultra-luxury segment. That is a niche market, not a revolution. And without large enough revenue, there are not enough resources to develop next-generation motors at a scale that can compete with Tesla. Rivian is building something different: electric trucks and SUVs for the outdoor lifestyle. They have good design, loyal customers, and financial support from Amazon. But in terms of pure motor technology, they're still using a more conventional motor architecture, and the gap with Tesla grows wider with every new generation. Ford is the most interesting story among traditional automakers. The F-150 Lightning sold fairly well and proved that Americans are willing to buy electric trucks. But Ford still depends on outside battery and motor suppliers, and it has had to cut EV production targets several times because costs got out of control. With a business model split between gasoline and electric vehicles, Ford cannot bet everything on new motor technology the way Tesla can. GM has poured nearly $35 billion into electrification, but the Ultium platform, once expected to become the foundation of its future, has suffered from delays and real-world deployment problems. The Cadillac Lyriq and Chevrolet Equinox EV are good products, but they have not created any technological wow moment comparable to what Tesla just did. And then there is BYD. This is the name Tesla has to watch most closely. This Chinese company has surpassed Tesla in total global electric vehicle sales. It has a better vertically integrated supply chain than most other automakers, making its own batteries, chips, and many key components. Its production costs are significantly lower, and it is pushing hard into Europe, Latin America, and Southeast Asia. However, BYD still has one important weakness. Its brand and software ecosystem are not strong enough in the United States. American consumers, especially those aged 45 and above, still tend to trust familiar brands more than unfamiliar new names. And until BYD truly enters the American market at a large scale, something blocked by tariffs and trade policy, Tesla still keeps its home field advantage. The key point is this: no rival is truly threatening Tesla on every front at once. Lucid has engineering but lacks scale. BYD has scale but lacks brand strength in America. Ford and GM have brand power but lack both. Meanwhile, Tesla has everything and has now added a motor that no one else can currently copy. So in the end, the biggest question remains: is this technology truly powerful enough to change the future? When an electric car motor goes beyond electric cars, this is the part that makes the story truly big, bigger than any single car or any single race. During the presentation of the new Plaid motor, Elon Musk said something that many people overlooked because they were focused on the performance numbers. He suggested that this motor, with its superior power-to-weight ratio, thermal stability, and ability to run at high speed for long periods, has potential applications far beyond automobiles. Think about electric aviation. One of the biggest barriers for electric aircraft so far has been the propulsion system. The motor has to be light enough not to add too much weight, but powerful and reliable enough to operate safely. Many startups are pursuing electric vertical takeoff and landing aircraft, but they all run into the same problem. Current motors are either too heavy or not efficient enough across the required speed ranges. Tesla's Plaid motor with a carbon sleeve could be the answer. Light, powerful, thermally stable, and capable of operating at high revolutions per minute for long periods without losing performance. These are exactly the qualities the electric aviation industry is looking for. Tesla has not officially announced any plan to license this motor to the aviation industry. But the indirect signals are already fairly clear, and if that happens, Tesla will no longer just be a car manufacturer. It will become a hardware supplier for a full-scale energy revolution. Think about energy infrastructure. Wind turbines, industrial pumps, large-scale energy storage systems, all of them need high-efficiency electric motors that can withstand harsh conditions. If Tesla can mass-produce Plaid motors at a steadily lower cost thanks to economies of scale, it could become the electric motor supplier for the entire clean economy, from vehicles to aircraft to the power grid. This is not science fiction. This is the logical next step for a company that already has gigafactories on 3 continents, produces megapack batteries for national power grids, and operates Powerwall solar energy systems for millions of households. Tesla is no longer just an electric vehicle company. It is becoming an energy and mobility platform for the 21st century. As for the competitors in the auto industry, they are trying to build a good electric car. Tesla is trying to build the infrastructure for a world without fossil fuels. Those are 2 completely different games in scale and vision. And the Roadster 2.0, the electric sports car Tesla has promised many times and repeatedly delayed, could be the final test of everything the Plaid motor can do. If it launches with the performance Tesla promised under 1 second from 0 to 60 miles per hour, more than 600 miles of range, and the full application of the latest motor technology, it will not just be a fast car. It will be the strongest technological statement any car company has ever made. The game is not over, but Tesla is reshaping the game from the beginning, once again. So we have gone through a long journey from the first Roadster in 2008 to the motor wrapped in carbon fiber with micrometer level precision today. But I want to pause for a moment and speak directly to you about the most important thing in everything we have just discussed. Tesla's Plaid motor technology is real. The performance numbers are real. The technical gap between Tesla and its rivals in motor engineering, at least at this moment, is real. But the history of technology has taught us that a technical gap does not always decide who wins the commercial race. Betamax was technically better than VHS, but VHS won. BlackBerry had a physical keyboard better than any touchscreen phone at the time, but the iPhone changed everything. Nokia dominated the phone market for years, then almost vanished overnight. The electric vehicle market is still taking shape. Consumers are becoming smarter. Government policies on EV incentives can change. Battery prices are falling quickly, and that can narrow anyone's cost advantage. And in a shifting geopolitical environment, decisions about supply chains and tariffs can reshape the game in ways no one can predict. So yes, Tesla has just done something incredible with this new Plaid motor. But is this truly the end of the electric vehicle industry as we know it? Are rivals really unable to catch up, or are they secretly developing breakthroughs of their own that we do not know about yet? Honestly, I do not know. And anyone who claims they know the answer for sure, you should be skeptical of them. What I do know for sure is this. What is happening in the electric vehicle industry right now? Fierce competition, technical breakthroughs, price wars, the infrastructure race, all of it is shaping the future of transportation around the world. And what happens in the next 3 to 5 years could decide the shape of this industry for decades to come? What do you think? Has Tesla really ended the game with this new motor? Or can competitors from Lucid to BYD to names we have never even heard of still create surprises? I would love to hear your opinion. Leave a comment below, especially if you own a Tesla or are thinking about buying an electric car. Share your real thoughts. Those are the most valuable perspectives. If this video showed you something new about the electric vehicle revolution, hit like to help this video reach more people. And if you want to keep following deep analysis like this, not just about Tesla, but about the entire picture of technology and energy that is changing the world, subscribe to the channel. Imagine an ordinary morning. You wake up, drink your coffee, then walk out to the garage and plug in your electric car before heading to work. It takes just 15 minutes, enough time to finish reading the newspaper, and your car is fully charged. You drive 500 miles without stopping once. No fear of running out of battery, no worry about the car losing value after a few years. The battery still feels almost new after 15 years of use. Sounds like science fiction? It is not. This is what Tesla is promising to turn into reality, and not just as a promise on paper. For years, people believed traditional lithium-ion batteries were the ceiling of electric vehicle technology. That we were already close to the maximum of what chemistry could do. That the next major leap, if it ever came, would still take another 2 or 3 decades. But things are changing faster than anyone predicted. In early 2025, Tesla quietly rolled out a chain of technical changes that, according to industry analysts, could become the biggest turning point in the history of electric vehicle batteries since the first Model S rolled onto the road in 2012. This is not a small improvement, not a normal optimization. It is a completely different approach to the battery problem, from materials to structure to manufacturing process. And on the other side of the Pacific, BYD, the Chinese giant that has sold more electric vehicles than Tesla for several consecutive quarters, suddenly realized it was facing a rival that was no longer just following behind, but moving ahead with a very different kind of breakthrough. So what makes Tesla's new battery technology so special that the entire industry has to pay attention? Why is BYD, long seen as a dominant force in the global electric vehicle market, feeling pressure from this move? And is this truly the turning point that could change the entire auto industry? Or is this just another case of Elon Musk promising more than engineering can actually deliver? Before we go deeper into the story, if you enjoy detailed analysis videos like this about technology and electric vehicles, do not forget to subscribe to the channel and turn on notifications, because what is about to happen in this industry is something you will not want to miss. Where is the battery world right now, and why does it need a revolution? To understand why Tesla's new technology matters so much, we need to look back at the bigger picture of the electric vehicle battery industry, and honestly, that picture is not entirely beautiful. Electric vehicles have grown dramatically over the past decade. Global sales increased from fewer than 1 million vehicles in 2015 to more than 14 million vehicles in 2023. But behind that growth, there are still stubborn barriers that the industry has not solved. The first problem is driving range. Even though things have improved a lot, most electric vehicles still make consumers worry about range anxiety, the fear of running out of battery on the road. For Americans living in suburbs or rural areas, where daily travel distances can reach several hundred miles and charging stations are still spread thin, this is not a small concern. The second problem is charging time. Even though fast charging technology has improved, charging from 20% to 80% still takes at least 20 to 30 minutes, even with the fastest charging systems. Compared with 5 minutes to refuel a gasoline car, this is still a big gap in the user experience. The third problem, and this is talked about less often but is just as important, is battery degradation over time. An electric vehicle after 8 to 10 years may lose 20 to 30% of its battery capacity. That does not just affect driving range, it also creates anxiety about used car value, an extremely sensitive issue for American customers who are used to gasoline cars holding value fairly well after many years. The fourth problem is cost. The battery accounts for around 30 to 40% of the total cost of an electric vehicle. For electric vehicles to truly compete with gasoline cars in the mid-range price segment under $35,000, the industry needs to cut battery costs to a level that no one has sustainably achieved yet. These are the four major problems that hundreds of companies, thousands of scientists, and billions of dollars in investment are trying to solve every single day. And this is exactly why, when Tesla says it has found a new path, the whole world has to listen. But to understand why this matters so much, we need to look at the core of the entire story, what Tesla calls its next-generation battery. Tesla's new battery technology, not just a better battery pack. The term solid-state battery has probably appeared in many videos and articles you have seen before. It sounds familiar, but do not misunderstand it. What Tesla is doing is not exactly the same as what you may have heard in the past. First, we need to understand why traditional lithium-ion batteries, the kind found in almost every electric vehicle today, have limits. In a normal lithium-ion battery cell, lithium ions move through a liquid called an electrolyte to create electric current. That liquid has a problem. It is flammable, it breaks down over time, and it becomes less efficient when temperatures change. This is why electric vehicle batteries perform worse in winter, and it is also why batteries gradually degrade after hundreds of charge and discharge cycles. A solid-state battery replaces that liquid with a solid material, usually ceramic or a special polymer. The theoretical result? Much higher energy density, longer lifespan, greater safety, and better performance across wider temperature ranges. It sounds simple, but for nearly 2 decades, the industry has struggled to make solid-state batteries commercially real. The problem is this: when you charge and discharge a solid-state battery many times, the contact area between the solid electrolyte and the electrode begins to break apart, creating tiny cracks that make the battery lose its ability to conduct electricity over time. Tesla is not the first company to recognize this problem, but it may be the first company to find a way to solve it at industrial scale. According to information from Tesla patents filed in 2024 and 2025, as well as reports from several industry sources, Tesla is using a method called the dry electrode process, combined with a new generation of solid electrolyte material based on sulfide compounds. This not only addresses the durability problem, but also, and this is the most important point, allows production at a significantly lower cost. While most other companies produce solid-state batteries using a wet process that requires expensive and complicated chemical solvents, Tesla's dry process removes that step completely. The result is a production line that is leaner, cheaper, and faster. But here's the interesting part. Tesla did not invent the dry electrode process. It acquired the technology from a small company, Maxwell Technologies, in 2019. And Tesla has spent nearly 6 years turning that lab technology into something that can be mass-produced. So, what is the result of those 6 years? It may sound simple, but this small detail is exactly what could change the entire game. The real breakthrough. 3 numbers that shocked the whole industry. To understand the importance of this new technology, look at the 3 numbers Tesla is aiming for and compare them with today's reality. The first number, 500 watt-hours per kilogram. Energy density, meaning how much energy you can pack into 1 kilogram of battery, is the most important metric in the world of electric vehicle batteries. The best lithium-ion batteries today reach around 250 to 300 watt-hours per kilogram. Tesla's new generation solid-state battery is designed to reach 500 watt-hours per kilogram, almost double. What does that mean in real life? A car with the same battery weight could travel twice as far. Or with the same driving range, the battery pack could be half as heavy, making the vehicle lighter, more efficient, and cheaper to produce. The second number? A full charge in 15 minutes. If Tesla achieves this, it could completely erase the final reason many people still hesitate to switch to electric vehicles. Solid-state batteries allow much faster charging than liquid-based batteries because they do not overheat in the same way. Tesla is aiming for the ability to charge from 10% to 90% in 15 minutes using a 350 kilowatt power source, a standard already available at many Tesla supercharger stations. The third number, a 1 million mile lifespan. This may be the most shocking number of all. A normal lithium-ion battery is designed for around 500 to 1,000 charge and discharge cycles before its capacity drops to 80%. Tesla claims its new generation battery can handle more than 3,000 cycles, equal to more than 1 million miles of driving. This number is not only suitable for personal cars, it opens the door to trucks, buses, and especially robotaxis, where vehicles operate continuously, 24/7. But numbers are not everything. What matters even more is production capability. No matter how good a technology is, it means nothing if it cannot be produced at large scale. Gigafactory and the mass production challenge. This is where Tesla has an advantage that not many people talk about. Manufacturing infrastructure. Tesla is operating Gigafactory Nevada, the largest battery factory in the world by floor area, along with gigafactories in Texas, Berlin, and Shanghai. These factories are not just production sites, they are industrial-scale laboratories where Tesla constantly tests and fine-tunes its processes. The dry electrode process that Tesla is deploying does not require extremely expensive clean rooms or toxic chemical solvents like traditional battery production. That means when Tesla scales up, costs do not increase in a straight line. Instead, they fall along the learning curve. Elon Musk has said many times that the hardest part is not designing the product, but designing the factory that makes the product. And in this case, Tesla has had 6 years to design both at the same time. According to several analyses from industry consultants, if Tesla reaches its cost target of $60 per kilowatt hour for its new generation solid-state battery, compared with the current $100 to $120 per kilowatt hour for the best lithium-ion batteries, then the production cost of a Model 3 or Model Y could fall below $30,000 while still remaining profitable. That is the threshold the entire electric vehicle industry is trying to reach. At this point, you may be thinking, why has no one done this before? The answer is, they have tried, and many have failed. Let's be honest about the challenges Tesla is still facing. Challenge number 1. The dry electrode process is still not fully stable at large scale. Tesla has admitted in several quarterly reports that scaling this process from pilot production to mass production has been harder than expected. In 2023, it set a goal to produce 100 gigawatt-hours of new generation batteries by the end of that year. The actual number was much lower. This is not the first time Tesla has missed a deadline. Challenge number 2. Sulfide electrolyte materials have a moisture problem. Sulfide compounds, the type of solid electrolyte material Tesla is believed to be using, are extremely sensitive to moisture. Exposure to normal air can damage them. That requires an ultra-dry manufacturing environment, a requirement that is both expensive and difficult to maintain at industrial scale. Challenge number 3. The dendrite problem has still not been fully solved. This is the oldest technical problem in solid-state batteries. When a battery is charged and discharged again and again, tiny metallic fibers called dendrites can form and pierce through the solid electrolyte layer, causing an internal short circuit and, in the worst case, a fire. Scientists have greatly reduced this problem, but no one has completely solved it yet. Challenge number 4. Low temperatures are still a weakness. Solid-state batteries, even though they are better than liquid-based batteries in many ways, still lose performance in deeply cold temperatures. That matters for consumers in northern U.S., states where winter temperatures can drop below minus 20 degrees Celsius. Challenge number 5. Competition from alternative technologies. While Tesla is pursuing solid-state batteries, other manufacturers are betting on improved lithium iron phosphate batteries, sodium-ion batteries, or even aluminum-air batteries. There is no guarantee that Tesla's chosen path will be the winning one, and this is exactly where the race becomes more intense, because Tesla is not the only company trying to dominate the future. What are BYD, Toyota, and the other giants doing? When talking about BYD, we have to acknowledge an impressive fact. In 2023, for the first time in history, BYD sold more electric vehicles than Tesla. Not just slightly more, but significantly more, with total sales exceeding 1.5 million vehicles in just 1 year. BYD is not just a car maker. It produces its own batteries, specifically lithium iron phosphate batteries under the Blade Battery brand. Blade Battery has solved 2 important problems. Safety, because it does not catch fire like conventional lithium batteries in most situations, and cost, because lithium iron phosphate is much cheaper since it does not use cobalt or nickel. But BYD is not stopping there. In late 2024, it announced that it was developing its own solid-state battery, with a goal of commercialization in 2027. Not only that, it is also investing heavily in ultra-fast charging technology, specifically a 1,000-volt system that allows 400 kilometers of driving range to be charged in just 5 minutes. 1 minute. 5 minutes. That is not a typo. So, who is winning this race? The answer depends on what you are measuring. If we measure by current sales, BYD is winning. If we measure by charging infrastructure, Tesla is winning. The supercharger network is still the largest and most reliable charging network in North America. If we measure by software and artificial intelligence integration, Tesla is clearly winning its autopilot, and full self-driving systems are still leading. If we measure by overall production cost, BYD has the advantage in the mid-range and budget segments. If we measure by future battery technology potential, that is the biggest unknown. Toyota, a surprising name in this race, has invested tens of billions of dollars into solid-state batteries and says it will have a commercial vehicle with solid-state batteries in 2027 to 2028. Toyota has the advantage of manufacturing experience and a global dealer network, but it is often seen as moving more slowly in the electrification transition. Panasonic, Tesla's longtime battery partner, is also racing. It is building a new battery factory in Kansas with the goal of supplying next-generation batteries to Tesla starting in 2026. QuantumScape, a startup backed by Volkswagen, is one of the most closely watched companies in the solid-state battery field. But it is also facing similar scaling challenges. And in South Korea, Samsung SDI and LG Energy Solution, 2 of the largest battery suppliers in the world, are also developing their own solid-state batteries with supply contracts for many major car makers. This is not a 2-horse race. It is a marathon with many participants on a track where the rules are still being rewritten every single day. So in the end, the biggest question remains: is this technology really powerful enough to change the future? If Tesla succeeds, what will the world look like? Let's step into a hypothetical scenario, but not a science fiction one, in the year 2028. Tesla has successfully commercialized its new generation solid-state battery at large scale. Battery costs have dropped to $60 to $70 per kilowatt hour. The base version of the Model 3 costs $27,000 before tax. Driving range reaches 500 miles on a single charge. Charging to 80% takes less than 20 minutes. What happens next? For American consumers, the barrier to switching to electric vehicles almost disappears. The price competes directly with gasoline cars, the driving range completely removes range anxiety, and charging time is no longer a major inconvenience. According to analysis from Bloomberg NEF, if this scenario happens, electric vehicle market share in the United States could exceed 60% by 2030 instead of 25 to 30% as currently forecast. For the oil industry, gasoline and diesel demand from transportation, which currently accounts for around 40% of total global oil demand, would begin to decline at a speed that cannot be reversed. Major oil companies have already noticed this. Many people in the industry predict that peak oil demand, the point when oil demand reaches its maximum, could arrive a decade earlier than previously expected. For the power grid, the explosion of electric vehicles would put enormous pressure on the national grid, especially if millions of vehicles charge at the same time. But it also creates an opportunity. Electric vehicles could act as mobile batteries for the grid, releasing energy back during peak hours through vehicle-to-grid technology. Tesla has tested this feature in Australia and several European markets. For BYD and Chinese competitors, if Tesla leads in solid-state battery technology, Chinese automakers, which currently have an advantage because of low costs, will face new competitive pressure. But do not underestimate their ability to catch up. China is investing around $15 billion per year in battery research and development, a figure that rivals any country in the world. For the labor market, solid-state battery factories may require different skills compared with traditional lithium-ion battery factories. This could create new job opportunities for highly skilled engineers and technicians, but it also creates challenges for current battery workers who need to transition. For robotaxis and autonomous transportation, perhaps the biggest and least discussed impact is on the robotaxi market driverless self-driving cars. Elon Musk has said many times that Tesla's future is not just about selling cars, but about operating autonomous vehicle fleets. With a battery that can last 1 million miles, the robotaxi business model becomes more realistic than ever. One car could operate continuously for many years without needing a battery replacement. We have gone through a long journey from the limits of traditional lithium-ion batteries to Tesla's dry electrode technology, to shocking numbers about energy density and battery lifespan, to the technical challenges still waiting to be solved, and finally to the future that could appear if everything goes according to plan. So what is truly important here? The important thing is not just that Tesla is developing a better battery. The important thing is that if Tesla succeeds, the entire competitive equation in the auto industry will change. Cost, performance, and user experience, the three factors that decide market share, could all shift at the same time, in the same direction, and at a speed no one can accurately predict. BYD understands this, Toyota understands this, Volkswagen understands this. And that is why all of them are pouring billions of dollars into the solid-state battery race, not because they want to, but because they have no choice if they want to survive in the auto industry of the next decade. But let's be honest, the future still has many unknowns. Tesla has promised big things many times and missed deadlines, from the Cybertruck to the new Roadster, from the solar roof to full self-driving. There is no guarantee that its solid-state battery will arrive on schedule, or that costs will fall fast enough to change the game before BYD or Toyota catches up. And the electric vehicle market still depends on many factors beyond the control of any single company. Tariff policy, raw material prices, the speed of charging infrastructure construction, and just as importantly, consumer mindset and habits, which change much more slowly than technology. But one thing is clearer than ever: the race has begun, and no one can turn back now. The question is no longer, will electric vehicles replace gasoline cars? The question now is, who will shape the next generation of batteries? Who will control the core technology of the electric vehicle economy? And consumers like us, people who will have to live with our car buying decisions for the next 10 or 15 years, who should we bet on? That is a question no video can answer definitively, but it is a question all of us should think about. What do you think? Do you believe Tesla will really make its solid-state battery promises come true? Or do you think BYD or another name will reach the finish line first in this race? Leave your thoughts in the comments below. I read every comment and would really love to hear your perspective. If this video was helpful to you, leaving a like is the best way to support the channel and help this content reach more people. And if you have not subscribed yet, this is the perfect time because the battery revolution story is not over and we will continue following it together. See you in the next video. Imagine this. You are sitting inside one of the most modern electric cars on the market. The kind of car that just a few years ago you were probably dreaming about because it had the most advanced technology of its time. A huge screen, a powerful battery, smooth acceleration. You are happy with it and you believe this is the future. Then suddenly, one evening you open YouTube and watch a clip of a very familiar public figure saying, "The thing you are driving right now is already outdated." Elon Musk, the man who was once laughed at when he said he would sell tens of thousands of electric cars every month, the man who was once called crazy when he said he would send humans to Mars for a second time. And almost every single time, he proved his critics wrong and showed that the things he talked about could actually become real. So what is Musk talking about this time? He has just hinted at a completely new kind of engine technology. Not a small improvement, not an upgraded version, but an entirely different propulsion mechanism. Something that, according to many people who closely follow Tesla, could be described as an electric jet engine. Does that sound like science fiction? Maybe. But remember this. Lithium batteries were once science fiction, self-driving cars were once science fiction, and SpaceX reusing rockets was once considered impossible by almost the entire aerospace industry. What makes this announcement especially dangerous for Tesla's rivals is not just the technology itself, it is the timing. While General Motors, Ford, Volkswagen, and dozens of other brands are spending billions of dollars trying to close the gap with Tesla in the traditional electric vehicle race, Musk seems to be preparing to change the rules completely. He is not just trying to run faster on the old track. He is trying to open up a brand new track that no one else is ready for. But this is what makes the story truly fascinating. No one knows for sure how this technology actually works. No one knows when it will really appear on public roads. And more than a few experts are asking whether this is a real revolution or just another flashy performance from a man famous for making huge promises. So, what makes this technology different from everything that came before it? Why should Tesla's rivals be this worried? And could this be the real turning point for the global electric vehicle industry? Or is it just another big promise waiting for time to judge? That is exactly what we are going to explore together in today's video. Before we dive deeper into the story, if you enjoy in-depth analysis like this about electric vehicle technology and the engineering breakthroughs that are reshaping the future, do not forget to subscribe to the channel and turn on notifications so you do not miss the next videos. When the electric vehicle race is reaching its most intense moment, to understand why Elon Musk's latest statement caused such a shockwave, we need to step back and look at the bigger picture of the global electric vehicle industry over the past several years. About 15 years ago, electric cars were something most people only saw in short news segments at the end of the day, or at technology exhibitions where everyone nodded and praised the idea, but almost no one actually believed they would drive one home. The batteries were weak, the range was short, charging infrastructure barely existed, and the price only made sense for a very small group of people. Back then, electric cars were a good idea, but they were not yet a practical product. Then Tesla appeared and everything began to change in a way almost no one expected. The Model S was not just an electric car, it was a statement. For the first time, an electric car was not only clean and efficient, but also beautiful, fast, and fun to drive. Its driving range crossed an important psychological barrier. Autopilot made people start thinking seriously about an autonomous future. And the giant touchscreen in the middle of the car made the interior feel like something that had stepped out of the next century. Tesla was not just selling cars. Tesla was selling a vision, and millions of people bought into that vision. But here's the interesting thing about major markets like the United States. Once an idea has been proven possible, the giants start waking up. General Motors, the company that once stopped production of the famous EV1 in 1999 and was heavily criticized for it, began rebuilding its entire strategy. Ford announced multi-billion-dollar investments in electric vehicles. Volkswagen set a goal to sell millions of electric cars every year by the middle of this decade. Even Toyota, the world's longtime hybrid leader, was forced to announce a much broader shift toward electrification. And that does not even include the completely new players. Rivian came in with powerful electric pickup trucks. Lucid Motors pushed range to record levels. And in Asia, especially China, an entire domestic electric vehicle ecosystem is rising at an unbelievable speed. BYD is no longer only competing with Tesla in the affordable segment, it is moving into the premium segment. NIO is building a battery swapping network instead of relying only on charging. Xiaomi, the smartphone giant, just launched its first electric car and sold out within minutes. The race is no longer Tesla running alone. And this is the key point you need to understand if you want to feel the weight of what Musk just announced. In such a brutally competitive environment, when dozens of brands are throwing tens of billions of dollars in the same direction, Tesla's advantage is slowly shrinking. Not because Tesla's getting weaker, but because the world is quickly catching up to what Tesla built over the last decade. Software, range, charging systems, premium interior design. All the things Tesla once had almost to itself are now becoming industry standards. So if you were Elon Musk and you see the crowd catching up with you on the old track, what do? You change the track. But to understand why this announcement matters so much, we need to look straight at the heart of the whole story, the technology itself. What is an electric jet engine, and why is it completely different? First, let's be clear about one thing. Calling this an electric jet engine sounds dramatic and attention-grabbing, but it is actually describing an engineering principle with a very real foundation. We are not talking about a car with wings, and we are not talking about something that breaks the laws of physics. We are talking about applying the core operating principle of a jet engine, combining it with electric power, and creating a completely different kind of propulsion system. Let me explain this in the simplest way possible. A traditional electric car, including today's Tesla vehicles, works like this. A lithium-ion battery stores electricity. That electricity is sent to one or more electric motors, and those motors directly turn the wheels through the drivetrain. Simple, efficient, and already proven. That is why modern electric cars can accelerate so quickly, because electric motors deliver instant torque from the moment they start, unlike internal combustion engines that need time to build pressure. But this system still has one basic weakness. The entire power and range of the vehicle depends completely on how much energy the battery pack can store. And that has been the biggest bottleneck in the electric vehicle industry from the very beginning. The bigger the battery, the longer the range. But the bigger the battery, the heavier the car. The heavier the car, the more energy it needs to move the same distance. This is a vicious cycle that has frustrated engineers for decades. And then there is charging time. Even though fast charging technology has come a long way, an electric car still needs at least 20 to 30 minutes at the fastest charging stations to take in enough energy for a long trip. Compared with around 3 to 5 minutes to fill up a gasoline tank, that is still a real psychological gap for many drivers. Now think about how a jet engine works. In a traditional jet engine, air is pulled in, compressed to extremely high pressure, and then fuel is burned to create powerful thrust. Most of that thrust comes from high-speed air shooting out the back, not from friction with the ground. That is why airplanes do not need wheels to keep moving once they are in the air. They are being pushed by air. The idea Musk appears to be pursuing is a system that pulls in and compresses air using electricity instead of fuel combustion. If successful, this could create thrust without depending completely on wheel friction. And here is the interesting part. A system like this could theoretically operate with a much smaller battery pack because it would not need to store enough energy to spin the wheels across the entire trip. Instead, it would need enough energy to maintain a high-pressure airflow, a process that could be much more efficient under certain conditions. On top of that, because some of the thrust would come from air instead of entirely from the wheels, the vehicle could maintain more stable performance on rough surfaces. Rain? Snow? Muddy roads? Conditions that can seriously reduce the performance of regular electric vehicles might be handled better if thrust comes from air instead of only from the tires. At first, this may sound like just an interesting technical detail, but that small detail is exactly the kind of thing that could change the entire game if it can be done successfully. The real breakthrough is not speed. It is breaking free from the battery trap. Now we get to the key point that not enough people mention when they talk about this technology. When most people hear the phrase electric jet engine, they immediately think about speed. They imagine a Tesla launching from 0 to 100 kilometers per hour in less than 2 seconds. And yes, if this technology is successfully developed, that kind of performance is absolutely within reach. But that is not the biggest leap forward. The biggest leap forward is something electric vehicle engineers have been losing sleep over for the past 15 years: breaking free from dependence on lithium. Look at the supply chain of a modern electric car. To produce a lithium-ion battery pack powerful enough for a mid-range car like the Tesla Model 3, you need a significant amount of lithium, cobalt, nickel, and manganese. These minerals are not unlimited. They are not found everywhere, and extracting them leaves serious environmental damage behind. Cobalt is the clearest example. A large share of the world's cobalt comes from the Democratic Republic of the Congo, a country that already faces deep political and social instability. Reports about working conditions in cobalt mines have shocked the international public many times. Electric vehicle manufacturers, no matter how good their intentions may be, still depend on that supply chain. And cobalt prices can swing so sharply that one sudden price spike can wipe out the profit from an entire year of production. If Musk really can develop a propulsion system that significantly reduces the size of battery packs or removes dependence on large lithium batteries altogether, this would not just be an engineering victory. It would be a geopolitical victory, a supply chain victory, and an environmental sustainability victory all at once. A car powered by an electric air propulsion mechanism would need less battery capacity. Less battery capacity means less lithium. Less lithium means less dependence on problematic mining regions. And the entire cost structure of electric vehicle production could be rebuilt from the ground up. But there is a third factor that people talk about even less, and it is the one that could force Tesla's competitors to rethink everything from the beginning. If the basic propulsion mechanism of electric vehicles changes completely, then everything rivals have invested in optimizing traditional battery and electric motor systems may no longer be a major advantage. Billions of dollars poured into next-generation battery research and development could suddenly become investments aimed at a technology that may already be on the path to being left behind. This is exactly what happened when electric vehicles began to truly compete with gasoline cars. Manufacturers that had invested too heavily in internal combustion engines suddenly found themselves holding outdated weapons in a war that was changing. History may be getting ready to repeat itself, but this time with the very companies that benefited from the previous shift. Still, no matter how good a technology sounds, it does not matter if it cannot be produced at scale. And this is where the story becomes much more complicated. The challenges no one should ignore. Let's be honest, this is the part that many YouTube videos about Elon Musk tend to skip or rush through quickly before going back to excited praise. But if you really want to understand this story, you need to look at the challenges honestly. The first and biggest challenge is whether this can actually work in real-world conditions. The principle behind an electric jet engine is not baseless, but applying it to a real road vehicle, one that has to handle potholes, storms, dust, and the extreme winter temperatures of Minnesota or the extreme summer heat of Arizona, is a completely different engineering problem. Jet engines on airplanes are maintained under extremely strict schedules after every few hundred hours of flight. A family car needs to run for tens of thousands of kilometers with minimal maintenance, and it cannot suddenly fail in the middle of the road. Compressing air at high pressure requires highly precise mechanical parts. Those parts wear down over time. Temperature, humidity, and air pollution all affect performance. And any failure in a high-pressure system on a road vehicle could create dangerous situations in a completely different way from a regular electric car simply running out of battery. The second challenge is early production cost. Tesla learned this expensive lesson with the Cybertruck. The design was extremely impressive, but the production process was so complicated that it took years to reach meaningful volume. With an entirely new engine technology, the supply chain does not yet exist, parts suppliers are not prepared, and assembly workers are not trained. Early production would almost certainly be more expensive, slower, and riskier than expected. The third challenge is regulation. The United States has an extremely strict vehicle safety approval system. Any new type of propulsion system has to go through thousands of hours of testing and evaluation before it is allowed on public roads. With a technology that has no real precedent, like an electric jet engine for cars, the National Highway Traffic Safety Administration is not going to rush to sign off on approval, no matter who is proposing it. And then there are international markets. The European Union, China, Japan, each region has its own approval process. Tesla once spent months convincing European regulators to accept certain autopilot software features. With a completely new propulsion mechanism, that process could take years. And finally, there is one challenge few people want to say out loud, but it really matters. Musk's expectations sometimes run far ahead of reality. Musk once said fully self-driving cars would arrive in 2020, then 2022, then 2023. Robotaxi has been delayed again and again. The Cybertruck eventually launched, but it arrived years later than originally promised. That does not mean Musk cannot deliver on what he promises. He can, but it often takes much longer than the original timeline. And with a technology as ambitious as an electric jet engine, that delay could be long enough for rivals to find a response. And this is exactly when the race becomes even more intense, because Tesla is not the only player trying to shape the future of the industry. Who is standing on the other side of this race? To properly understand the importance of Tesla's new technology, we need to place it inside a competition that is becoming broader, tougher, and more aggressive every year. Let's start with China's BYD. Not many people in the United States follow BYD closely, but that could be a costly mistake in terms of awareness. BYD is now the world's largest electric vehicle maker by sales. It develops its own lithium iron phosphate batteries, a type of battery that uses no cobalt, costs less, is safer in high-temperature conditions, and has a much longer charging life than traditional NMC batteries. BYD controls much of its own supply chain, from raw materials to final vehicle assembly, and it is expanding internationally at an astonishing speed, from Southeast Asia to Europe to South America. If Tesla changes the basic propulsion mechanism, BYD has both the engineering capability and the financial resources to respond quickly. It is not just a car maker, it is a massive energy technology company. Next is Lucid Motors. The Lucid Air still holds a record for driving range on a single charge among commercial electric vehicles in the United States, even beating Tesla. This is not because of a flashy performance trick, but because of real progress in battery energy density and electric motor efficiency. Lucid is proving that deep optimization of traditional battery technology still has a lot of room left, and that you do not necessarily need to change the entire propulsion system to achieve major improvements. Then there's Rivian, a brand that is steadily building a loyal user community in the electric pickup and SUV segment. Rivian is not competing directly with Tesla on every technical specification. Instead, it is creating a different reason to choose a vehicle based on community, outdoor lifestyle, and practical durability. And do not ignore traditional giants like Ford with the F-150, Lightning, and Chevrolet with the Equinox EV. Ford is trying to put electric vehicles into the hands of practical customers, people who never imagined they would drive a Tesla, by combining familiar design with electrified technology. This strategy is less flashy, but it reaches a group of customers Tesla has never fully touched. So, what does this competitive picture show us? It shows that even if Tesla's electric jet engine really works as advertised, the path to global market domination will not be a straight line. In today's electric vehicle world, better technology does not automatically mean winning the market. Price, distribution, after-sales service, brand familiarity, and government policy all matter just as much in the final equation. So in the end, the biggest question remains: is this technology truly powerful enough to change the future? What could the future look like if this works? This is the part where we step into the territory of possible scenarios, future directions that no one can guarantee for sure, but that are clear enough for us to recognize. The first scenario, and probably the closest impact, is a change in the map of charging infrastructure. One of the biggest barriers to electric vehicles in the United States is not the price of the car or even driving range, but the fear of not finding a charging station when needed. This is especially true for people living in suburbs or rural areas where charging networks are still thin. If the new technology significantly reduces the need for frequent charging or allows faster charging because the total energy needed is lower, this psychological barrier could disappear naturally without the government spending billions of dollars to expand the charging network. The second impact is at the level of mining and the global supply chain. If worldwide electric vehicle production continues growing along its current path, and every vehicle still needs a large battery pack like today, lithium demand will rise to a level that even the most active mining operations may struggle to meet in the short term. This is a real risk for the entire electric vehicle industry. A propulsion technology that depends less on batteries would not only be better for the environment, but also better for price stability and long-term production scalability. The third impact, and maybe the most interesting one for everyday drivers, is the question of long-term ownership cost. One of the strongest arguments for electric vehicles is that they cost less to operate than gasoline cars. Less maintenance, electricity is cheaper than gasoline, no oil changes, no filter replacements. If an electric jet engine is truly more durable because it has fewer friction parts, creates less heat, and wears down more slowly, then the cost of owning a vehicle over 15 to 20 years could shift in a way that benefits consumers far more than today. But perhaps the most shocking impact could be in a field completely outside cars: short-range aviation and cargo transport. Electric aircraft are one of the biggest engineering questions of this decade. The core principle of an electric jet engine applies more directly to aircraft than to cars. If Tesla and SpaceX work together to develop this technology toward aviation, short routes of 200 to 500 kilometers could become electric sooner than any current forecast suggests. And this is a massive market that Tesla has never even publicly said it wants to enter. Musk has never been someone who looks at only one industry. He looks at the whole ecosystem. Tesla, SpaceX, Neuralink, The Boring Company, Starlink. Every project serves a larger vision for how humans move, connect, and survive. If successful, the electric jet engine would not just be a product. It would be a platform that other industries could be built on. And when you look at the whole picture, you start to understand why Tesla's rivals are not just worried about a new car. They're worried about a company trying to reset the foundation of how the world moves energy and people. We have just gone through a pretty long journey, from the big picture of the global electric vehicle industry, to the technical nature of a technology no one has fully seen yet, to the potential impacts that could stretch all the way into aviation and mineral mining. But let me sum up the most important point. What matters about Elon Musk is not just each individual invention. What matters is the way he keeps choosing moments to change the rules right when the world thinks it already knows the answer. The electric vehicle industry is in a very strange stage right now, mature enough to become mainstream, but still young enough to be completely disrupted by the right breakthrough at the right time. And if the electric jet engine really can't overcome the technical and regulatory challenges we talked about, that disruption could arrive much sooner than many people expect. But here is something no one should ignore. The future is still completely undecided. The history of engineering breakthroughs is not just the story of people with the best ideas. It is the story of people who can turn good ideas into real products, deliver them on time, price them correctly, and convince enough people to believe in them to build momentum. Tesla has done that before. But doing it before is not a guarantee that it will happen again this time. There are hundreds of millions of people around the world, especially older generations in the United States, who have lived through enough big advertisements and grand promises from the tech industry to be cautious. They do not need to be convinced by statements. They need to be convinced by evidence. And that is exactly what Musk and Tesla will need to provide in the coming years. So the final question I want to leave you with is not whether this technology works or not. The question is, if it works exactly as claimed, what would it change in your life? The car you are driving, the electricity price you are paying, the national energy sources we depend on, and more broadly, America's position in a global technology competition that is getting hotter than ever? This is the question I really want to hear your thoughts on. Do you believe this is a real turning point, or is it just another big promise waiting for time to judge? Leave your opinion in the comments below. There is no right or wrong answer here, only different perspectives from people who are truly watching and thinking about the future. If this video gave you a few new perspectives, hit the like button to support the channel. And if you want to keep following in-depth analysis like this about electric vehicle technology, energy, and the breakthroughs shaping the world, do not forget to subscribe and turn on notifications. The race has already begun, and what happens over the next few years could become the most interesting chapter this industry has ever written. I will see you in the next video.